From the Library of Congress in Washington, D.C.
Good morning. My name is Elmer Huisman. I am the Chief Conservator here at the library, and wanted to welcome you all to the 80th TOPS lecture, Topics in Preservation Series. 80, I can't believe it. Before I introduce Andrew, who will introduce our speaker, I just wanted to announce that our next TOPS lecture will be Monday, September 12th. And it will deal with using computer tomography to digitally unroll and render the text from a circa 1500 BCE Elephantine Island roll of papyrus. So for those of you who are interested in that, Monday, September 12th. Here to introduce our speaker is Andrew Robb. Andrew is the head of the Special Format Conservation section, and in that role in charge of the conservation of the library's photographic material. Andrew.
Thank you, Elmer. A warm welcome to our speaker, Rachel Wetzel. She's very familiar to us here. In 2003, she was a summer graduate fellow with us, the Conservation Division, and it's wonderful to have her return to give this lecture on her work concerning the conservation of early daguerreotypes, a topic of great relevance, particularly to us in our collection, as well as to many others who are here in the audience and over the web. It'll be great to have this on our website, archived so that people in the future will be able to access this presentation. Rachel's been on the staff of the Conservation Center for Art and Historic Artifacts since 2007, where she's a conservator of photographs. In addition to her work as a conservator, she also conducts surveys, teaches photography-related courses and workshops at graduate schools, libraries, archives, and museums. And she's been an officer of the Photographic Materials Group of the American Institute for Conservation. Her educational background includes postgraduate work at the Advanced Residency Program in Photograph Conservation at the George Eastman Now Museum and the Image Permanence Institute, a master's degree in art conservation from the State University of New York, Buffalo State College, and a bachelor's degree from the University of Pittsburgh. Besides her work with daguerreotypes, she's published several papers on optical brightening agents and light bleaching of photographic material, so her research interests are broad, and we welcome that in our small field. Her presentation this morning is Conservation Science and the Daguerreotype, Preserving Our Earliest Photographic Treasures. Rachel.
Thank you. Can you all hear me okay? Great. Good morning. I'm very happy to be back here at LC. This is, sort of where I started my career in photo conservation, so it's nice to come back and give back to all of you, all of the things I've been working on recently. In today's lecture, I'll be taking you down the historic path of early photography, how that was invented, how it arrived here in America. We will be exploring a little bit of the improvements made to the daguerreotype process. I will be explaining exactly what a daguerreotype is. And then from all of those bits of information, I'll be able to explain to you a little better about why this project with early daguerreotypes and preservation is very important and necessary for the field of photo conservation. So try to imagine a time before there was photography, which right now is pretty hard to do since we all have cameras on our phones and it's extremely commonplace and easy to take a photograph. But if you just go back another century to the 19th century and the early part of it, there was no photography and people could not see a rendering of themselves or a portrait of a beautiful landscape outside. But the 19th century, the early 19th century is very centered around inventing some sort of photographic process. And it began pretty early in the 19th century. There were a lot of people experimenting and trying to do this, but with not much great success. And these people were scientists, they were some curious tinkerers, and they were all trying to find a way to sort of capture an image and maintain it on some sort of substrate. Only some of them would gain some success in doing so, but the silver would keep printing out until they had a dark piece of paper or a dark metal plate. But on January 17th, 1839, one person found a way to sustain an image on a metal plate, thus giving rise to the birth of photography. And that man was Louis-Jacque-Mandé Daguerre. He was a Parisian artist, and he is credited for inventing the first photographic process. And this is a daguerreotype that was taken of him. So Daguerre was a painter. He wasn't a scientist like a lot of the other people tinkering around with inventing photographs. He actually in the 19th century ran a very successful diorama studio in Paris. And the diorama was sort of 19th century theater, the sort of predecessor to motion picture film. And it was a room that utilized several trompe-l'oeil style landscape paintings that were illuminated in various ways that allowed the one painting to change in scenery from light to dark, making a very dramatic effect on one image. So the diorama provided a lot of entertainment for Parisians in the early 19th century. But to make these very large-scale paintings for the diorama, Daguerre utilized this piece of equipment called the camera obscura to project his sketches on a large-scale term. And it was with this particular apparatus that he started to play around with inventing what we now call photography. So I suppose you can say Daguerre was sort of a master of manipulating light in an artistic effect. So Daguerre's process, quite aptly named after himself, as many 19th century inventors would proudly call their photographic process something that included their name, was a sensitized silver plate that utilized a long exposure to produce a faint image on a mirror surface. But at last, this landscape that you could see in front of you could be contained on this delicate piece of silver. Proud of his amazing accomplishment, the daguerreotype was presented in front of the French Academy of Sciences in 1839, and it wowed the Parisian community. Never before had we seen a photograph. But Daguerre wasn't the only person. As I mentioned, there were a lot of people trying to experiment to make a photograph. But one other person that was sort of successful and was working at the same time as Daguerre was a man named Nicéphore Niépce. And Niépce lived a few hours away from Daguerre, and he was inventing this process called the heliograph, which utilized the action of light to harden an area of material on a metal plate to produce an image. Niépce set up his camera in the window of his country home, and in 1826 he captured this image on the right, and there's a view of Le Gras at his country home, and what we now know today to be the oldest photograph in existence. And this photograph is currently housed at the Harry Ransom Center at the University of Texas in Austin. This particular image on the right is what you see if you Google search the heliograph process or Niépce's photograph, and it's usually reproduced in a very contrasty and grainy way to make the image more visible. But 19th century photography was pretty crude, and what it actually looks like is on the right. So right now we look at this and we don't think it's really that spectacular, but in 1829 it was pretty phenomenal that this could, what he was looking out his window to see, he was actually capturing on this plate. So it's very rare and special and very sensitive and delicate, and might not look like the best composition of a photograph or the best shape of a photograph, but this photograph is very significant to the history of photography. So prior to 1839, Daguerre and Niépce were both working independently, and they were both happened to be buying lenses for their camera obscuras from a man named Charles Chevalier in Paris. And Chevalier knew of both men's work, and he suggested to one of the men that they perhaps collaborate on trying to make a photograph. And Daguerre was very interested in meeting with Niépce and trying to collaborate and maybe helping one another to sort of solve a lot of the issues they were having with the printing out of the silver and not being able to contain the image permanently, But Niépce did not want to meet with Daguerre. But Daguerre was very persistent, and he wrote several letters to Niépce over the course of a number of years, and eventually the two men agreed to meet and reveal the heliograph and the daguerreotype to one another. But unfortunately, Niépce passed away in 1833, so he never saw the official birth of photography in 1839. So there is one more man in this long trail of the birth of photography that is worth mentioning here, and that man is an Englishman named Sir John Hershel. Hershel discovered that sodium thiosulfate is a silver halide solvent in 1819, and eventually this became the key element to stopping the silver reaction when making a photograph. So this compound, sodium thiosulfate, if you've done any black and white photography, we call fixer today, and it's the one material in the process of development that will stop the silver halide reactions and make the silver permanent for stabilize the image for permanency. So it was Hershel's discovery that helped Daguerre stabilize his daguerreotype process and make his image permanent. So kind of without Hershel's discovery, Daguerre wouldn't be able to do his. So there's a lot of people contributing to the invention of photography at the time. And just shortly after Daguerre presented his process at the Academy of Sciences in Paris, Hershel was presenting his discovery of fixer at the Royal Society of London. So everything was sort of happening in 1839 based around this daguerreotype invention. So Daguerre's process created quite a bit of enthusiasm upon its announcement in 1839, and though he kept his formula secret, everybody wanted to make one of these daguerreotypes, but nobody knew how. So he was trying to coin the market, rightfully so. He needed to make a living, and he invented this process. So he was trying to sell subscriptions to have people buy his daguerreotype plates, but it just wasn't as successful as he would have liked it to have been. And Daguerre finally agreed with the French government to, in exchange for to be financed or have a salary from the French government, he had to release his daguerreotype formula. And this happened in August, so a number of months later after it was officially announced. And then daguerreotype mania began. So Daguerre's formula was quickly translated into several languages and distributed worldwide. It made its way to the United States in a ship in September of 1839. And however, while the daguerreotype formula would traverse the ocean, the actual idea of the daguerreotype existing had arrived in America long before that. So in January of 1839, when Daguerre was making his announcement, there was also a man from the United States, from New York, named Samuel Morse. And Morse was over in Paris presenting his new invention, the electromagnetic telegraph. And you may know Morse from Morse code. He's quite, he also made photographs, but he also invented quite a few things. And Morse thought his invention was going to be the hot topic in Paris, but unfortunately, all anybody could talk about was the daguerreotype. So being a curious-minded person, Morse needed to know what this daguerreotype was, and he went to Daguerre's studio, and he had a look at it, and he was just fascinated. So he wrote letters back to the United States to his colleagues telling them about this fantastic invention that was happening in Paris. So there was a lot of hype about the daguerreotype before we even knew how to make one here in the United States. So when the formula arrived in September of 1839, the first man in Philadelphia to attempt to make a photograph was this man, Joseph Saxton. So keep in mind, this is early photography. In 1839, you couldn't just go to a store and buy all your photographic equipment. You couldn't just buy a camera and a plate. You had to procure all of these materials and chemicals yourself, and you had to figure out how to construct your camera and how to measure out all the chemicals. It wasn't like you bought Kodak Fixer. So Saxton, according to the notes, made his camera out of a cigar box and a ground glass lens. But Saxton needed a metal plate to make his daguerreotype, and this on the right for you is the daguerreotype that he made from his window at the U.S. Mint. But to make this plate, he went down the street to a metalworking lighting shop called Cornelius and Company, where he requested silver-coated copper plates. And that man who made his silver-coated copper plates was a man named Robert Cornelius. So Robert Cornelius, and this is a later photograph of him, not only was a metal worker, but he had an interest and a background in chemistry. When learning of Saxton's experimentation with the daguerreotype, he too decided to give it a try. So Cornelius set up his daguerreotype camera in the back alley of his family's company shop, and he placed his sensitized plate in the camera, and he stood in front of the camera lens for quite a long time to take what we know today to be the very first self-portrait. So some of the facts you should know about the daguerreotype process in 1839. As I mentioned, the exposure times were quite long, so they could range anywhere from 3 to 15 minutes and upwards to a half an hour, depending on the light conditions outside and the brightness of the sun. The long exposures prohibited the capturing of motion. So if you see most of the early 1839 daguerreotypes are landscapes, and then if you look at them, you won't see any people in them. So Daguerre took a lot of street scenes of Paris, and there aren't any people in most of those daguerreotypes. And the reason for this is that because the exposure time could be up to a half an hour, if anybody was just walking by on the streets, they wouldn't get captured in the image. You'd have to stand still in the frame of the camera for a significant amount of time to appear in the daguerreotype. So a lot of people thought that Daguerre woke up really early in the morning when the streets weren't busy and took these photographs, but actually it's just the long exposure time that prohibits the motion being captured. So Robert Cornelius, after he made his self-portrait, he decides to collaborate with another chemist from the University of Pennsylvania. And if you've been to Philadelphia, you know Philadelphia Center City is quite small and compact. And all of these places were located sort of within a block or two of one another. So the University of Pennsylvania, the U.S. Mint, Cornelius's family business, the Franklin Institute, the American Philosophical Society, all these places I'm going to be talking about are within 5 minutes walk of one another. So at the University of Pennsylvania, there was a man named Paul Beck Goddard, and he was a chemist, and he had an interest in making daguerreotypes. And on the right here is a landscape daguerreotype that he made from his window at the University of Pennsylvania in 1839, and it belongs to the Franklin Institute. So because Cornelius had taken this self-portrait using the daguerreotype process, which, as I mentioned, had a very long exposure time, the two men saw this marketability in the daguerreotype for portraiture. However, because the exposures were so long, it really made this process unsuitable for rendering the likeness of a human image, as the sitter would have to sit perfectly still for a very long time, which, try to sit in your seat for the next 2 minutes and not move. It's really difficult. So together they experimented with the sensitization step of the process, and in order to reduce the exposure time of the plate, they replaced one halogen, which in Daguerre's original formula was iodine, with bromine. And first experiments showed that bromine had a little bit of hazing on the plate. So they were doing some experiments with iodine and bromine and then iodide again. But with these experiments and changing out the halogen, they were able to make the exposure time of the plate, they could cut it in half, which made still a long time to sit still, but way less excruciating than 15 minutes. So just a little side note of interest, bromine, the element, this wasn't even discovered until 1826. We're talking about 1839 right now, so this is just a little over 10 years after this element is even discovered. And legend has it that Cornelius and Goddard bought up all the bromine that they could possibly get in the area. So the Philosophical Society in Philadelphia and the Franklin Institute were the main two places where you would present new scientific discoveries. So Cornelius and Goddard presented these two particular daguerreotypes there at one of the annual meetings. And the one on the left is a portrait of Goddard. So this one was made before Cornelius's studio opened, but it would make sense that you would take a picture of your partner. So in 1840, these were presented with great praise at the American Philosophical Society to the scientific community. So Cornelius went on for the next year making portraits in his first studio at 8th and Lodge Alley. So if you are familiar with Philadelphia, it's 8th Street between Chestnut and Market, and Lodge Alley no longer exists. All of these images were made on plates that Cornelius made since he was a metal worker, and all of these images are housed in a very non-traditional metal frame style that Cornelius made himself. And these three examples are some of the variants you will see from his handmade housing samples. Additionally, on the verso of all of the Cornelius daguerreotypes, you will see a paper backing that contains a paper label with the Cornelius studio name. So this is sort of the way that an artist would sign his painting daguerreotype. This is the way to sign your daguerreotypes. So the following year in 1841, Cornelius set up a second portrait studio, and this one was on a second floor, and it had better natural lighting. And at this point, Cornelius had really kind of perfected his craft of portraiture in the short time that he was making daguerreotypes. And he was able to reflect the sun from his window onto his sitters in a way that made it much more painterly and scholarly. And with this era of portraiture, he also put his images into traditional leather cases that we use here in America. So daguerreotypes in Paris were put into these glass housing that were called passepartouts that contained a reverse painted glass. But in America, we traditionally used little leather embossed cases. But while you can't see the Cornelius paper label on these, he did emboss his brass mats with his name and his studio address on them, so you'll know which ones are Cornelius's. Cornelius also, he retired he had the studio from 1840, he closed it in 1843. There's not a lot of records left behind or notes from his studio. There aren't lists of people he took who were his sitters. So all that's left are the artifacts of his labor. So we know that Cornelius's family was in the lighting business, and the gas lamps were becoming very popular at this time. So whether he went back to work in his family's company out of necessity, or he just grew tired of making daguerreotypes, I'm not really sure. The latter seems feasible, but this is what you will read in the historic literature. But he closed up his shop in 1843, and he did make a handful of daguerreotypes post his, quote, retirement up until 1847. So as I mentioned, he didn't leave behind any logbooks. We don't have records of his studio, but the portraits that he left behind are really quite remarkable. And his first studio portraits were very straightforward images and bust from the waist up, and they were very nice and very skilled. But by the time he made it to his second studio, I think he really perfected his angles of his sitters, and his portraits became pretty phenomenal. And this is a comparison. On the left is the first studio, and the right is the second studio. And it's not just me saying that I think Robert Cornelius's portraits were pretty great. Daguerre himself found Cornelius's portraits to be pretty phenomenal as well. So Daguerre sent a mammoth plate daguerreotype of Notre Dame to the Franklin Institute. In this note on the back of the daguerreotype indicates that Daguerre was sending this particular daguerreotype to America in exchange for portraits made by Robert Cornelius. So to have the inventor of the process request your daguerreotypes is probably the highest honor you could have. However, all that remains of the legend of Robert Cornelius can only be deduced in this series of beautiful portraits he captured between 1839 and 1847 in the earliest era of photography in the United States. And as of now, there are fewer than 50 of his daguerreotypes known to have survived. And these are just some of the locations that hold Cornelius's daguerreotypes. So for those that don't know what a daguerreotype is, I will give you a little explanation. So it's a highly polished silver plate. It's most commonly a thin layer of silver coated over copper that has been smoothed to a mirror finish. And the process of making a daguerreotype goes as follows. Step number 1 is to prepare your silver coated copper plate by clipping the corners. This helps you with polishing. And the second step is to polish your silver plate to a mirror finish. This polishing takes many, many hours to do to get the daguerreotype smooth and shiny. And you will often see when you look at a daguerreotype and hold it in a certain angle that you can see the polish marks, and you can tell which direction they go, up or down or side to side. Number 3 is to subject the plate to vapors of halogen. And as I mentioned before, Daguerre's original formula used iodine, and then later it's what we call double sensitization, so it's iodine and bromine, or a combination of the two. And that made the plate light sensitive. At that point, you would place your plate in the daguerreotype camera to take the exposure. And after that was done, you would develop your images in the fumes of mercury. And to stop that silver reaction, this is where that fixer or sodium thiosulfate comes in. And then the next step in this timeline occurs post-1841 and doesn't apply to the earliest daguerreotypes, but there was a step called gilding, and this was a coating of gold chloride. And the gold chloride would be put on the surface of the plate, and I'll explain this a little bit more in detail later, but in the earliest of Cornelius's experiments, this step did not exist. And then the final step for all daguerreotypes was to seal them up, because this is a highly polished piece of silver and it tarnished quite readily. So they figured out pretty quickly that they needed to seal it in some sort of environment that would protect it from the atmosphere. So this is what the finished product of a daguerreotype looks like. And it's a little bit hard to see when you pick one up because it's a mirror and it's reflective. So at a certain angle, with a dark material blocking the reflectance, you can actually see the daguerreotype image. So you can see the woman here. And if you tilt it a little bit, the image appears more like a negative. So the silver changes and it makes the parts that stick out sort of recess. And if you tilt it even more, it just becomes a solid mirror, so you can see the reflectance of this newspaper in the image. So as I mentioned before, daguerreotypes needed to be sealed to slow down the sulfur and other pollutants in the atmosphere from tarnishing the silver plate. And I mentioned that the French used the reverse painted glass passepartout, and in America we use these embossed leather cases that were made into standard sizes. So the daguerreotype package would generally include a decorative brass mat that was placed directly on top of the daguerreotype plate. Over that, a sheet of glass would be put on top, and around the perimeter of this package, it was usually sealed off with some kind of paper tape with an adhesive. And then that tape would be covered by a brass preserver to cover the seal around the daguerreotype package. And the entire daguerreotype package would be fitted into one of these custom leather cases. And the leather, it was usually embossed leather, and there was, on the lid side, there was a material to help with the reflectance and viewing of the daguerreotype. So in this particular one I have on the screen, it's a solid piece of silk, and that's sort of the earlier style case, but later they became dark colored embossed velvet. So in addition to providing the daguerreotype with a special handheld housing, the cases and passepartouts served as protection from the harmful gases in the environment. Being pure silver, the plates had a tendency to tarnish if they were left bare and open to the elements. So on the left is an example where the tarnish is quite heavy, and the pattern that it forms corresponds to the shape usually of the brass mat that sat on top of it. Color interference rings would cover the surface, obscuring the image from the outside in. Daguerreotypes are also susceptible to abrasion, and that layer of silver that's coated on the copper is extremely thin. So if you touched it with your finger or some other material, you could easily disrupt the silver, and the copper beneath could be exposed. And if you have moisture in the environment, then copper corrosion can form, and little mushroom-like areas of copper byproducts can protrude to the surface of the daguerreotype. And you can see that in the daguerreotype on the right, the sitter on the left. One other common problem that daguerreotypes have for deterioration over time is that the glass that's placed on top of them also corrodes. And the glass will ooze out silica and other byproducts of the glass production into like stalactite formations that dangle down from the glass onto the the daguerreotype plate. So the oldest of the daguerreotype plates are at the greatest risk to these naturally occurring deterioration issues, and this is the Robert Cornelius self-portrait that's owned by the Library of Congress. And you can see on the right in this detail that the perimeter tarnishing is quite heavy. And these two Cornelius plates that I showed before exhibit a white haze around their perimeters, and these are the byproducts of historic cleaning. These two daguerreotypes are owned by the American Philosophical Society, and they were brought to me at the Conservation Center by the Philosophical Society's Conservator Anne Downey. And Anne was concerned that when she began working at her job that she had seen these, and then she looked at them fairly recently and she thought they had changed and had more tarnish and more hazing than she remembered when she started at her job. And she asked me if there was anything I could do to treat them. And I knew, being Robert Cornelius Daguerreotypes and looking at them, that they were some of the earliest daguerreotypes made here in America, and I told her there's no way I can just do a treatment on these two daguerreotypes. There has to be a huge research project. We don't have a lot of information about these early materials. So my first step was to telephone my colleague Adrienne Lundgren here at the Library of Congress, because I know she really loves daguerreotypes as much as I do, and I also knew that there was a large collection of Robert Cornelius's holdings here. So together we talked about, I explained my problem, and she was telling me that she had the self-portrait and it was not in very good shape either. So together we decided we needed to collaborate on a research project. So several issues that pose challenges for conservators with these materials. The primary issue is that the daguerreotypes that were made between 1839 and 1841 were not gilded. And I mentioned this gold chloride step in the production of the daguerreotype earlier. So the gilding added a protective layer to the silver image particles. It also helped make the image a little more durable and stable than their ungilded counterparts. The gilding also helped visually with some of the contrast of the image. So when you compare ungilded on the left versus a gilded image on the right, you can see the ungilded image is a little bit flatter. But both images, all daguerreotypes, are incredibly fragile materials. It just happens that the ungilded daguerreotypes are even more prone to abrasion, which limits a lot of the treatment options we have currently for gilded daguerreotypes, which comprises most of the body of daguerreotypes. So the tarnishing of the silver is the second issue that we need to consider. So tarnish was a problem from the beginning of production of daguerreotypes, as I mentioned, And so much so by 1850, it was very common that tarnish had already occurred on daguerreotype plates, and people in the 19th century were cleaning daguerreotypes with a solution of potassium cyanide. So with this cleaner, it might have worked miracles at the time, and it might have made the plate pretty shiny and new. But today, 177 years later, residual amounts of cyanide can be found on the surface of the daguerreotype plate. And you can see deterioration that was caused by the cyanide. So cyanide can be found on the daguerreotype plate for many reasons. Sometimes it was used in the production of the plate cladding, sometimes it was used in the development, and sometimes it could just be caused from historic cleaning. In this side-by-side comparison on the left, you can see the corresponding tarnish on the silver plate with the pattern of the fluorescent cyanide in the image next to it. So the image on the right is an image under ultraviolet light, under UVC, and it shows all of that fluorescence caused by the cyanide. So you can't see that with the visible eye. But you can look in the bottom right corner and see sort of a corresponding pattern of deterioration that is pretty aligned with the cyanide on the plate. And then later in the 20th century, in the 1950s, we had a new compound for cleaning silver called Thiourea. And Thiourea started to be used to clean daguerreotypes. And again, this was another compound that you would clean your daguerreotype with. Probably looked pretty great at the time. But now, 40, 50 years later, we are seeing a lot of white residues and hazing on daguerreotypes that were cleaned with Thiourea and likely not washed very well, or over-cleaned with Thiourea. And cleaning of daguerreotypes with this solution was pretty popular, so much so that it was published in a Time Life book series. It was in many photographic magazines. So a lot of people were cleaning their daguerreotypes, and not necessarily conservators or scientists. People just who had daguerreotypes read about this new cleaning method and were trying it out. So this will play a big part a little bit later on what we're dealing with today as conservators. So just to give you an idea, this is the daguerreotype of Paul Beck Goddard that the APS has, and this one was cleaned in Thiourea in the late 1970s. And I know this for a fact because there's a note on the back of this daguerreotype indicating so. So while I'm sure it looked pretty good at the time it was cleaned, now it doesn't look so great 40 years later, and you can see there's a white haze around the perimeter, so that area would have been the heaviest area of tarnish. So that Thiourea has left a really undesirable white hazing on the heaviest part of the silver, but there's also a haze overall. And then another result of these historic cleanings is what we call measles. So all on the right, if you look at that image, it's the same image in specular illumination, and you can see all of these brown tiny dots on the surface of the plate, and those are all residual byproducts of the historic cleaning. And here's a detail under the microscope. You can see this is the surface of the plate, and there are a bunch of abrasions and scratches, and I'm not 100% certain if these were products of Cornelius's working style or products of, a brush being applied to this daguerreotype plate when it was cleaned in the 1970s. But just to give you an indication of how easily these can be abraded, you can see it really makes a bunch of scratches on the surface which cannot be removed. But to make matters worse for this poor portrait of Goddard, I looked at it under ultraviolet illumination, and this one also has cyanide all over the surface. So it's likely it could have been cleaned twice with 2 different cleaners, which isn't an uncommon phenomenon for early daguerreotypes. And the portrait of Pierre Etienne DuPonceau, he survived a little bit better than Goddard. So his plate and specular illumination just shows a little bit of the hazing. But what I wanted to point out here is there are some distinct little polish marks on the plate, which we looked at and saw on a lot of early daguerreotype plates. And we were thinking that maybe at first these were significant and particular to Robert Cornelius, but we're finding on a lot of these old plates from 1839 that were hand done that there are these little tiny hash marks in them. But these could be, you know, a good indicator for authenticity of materials later. So conservation treatment of the daguerreotype is a rather controversial topic in the field of photograph conservation. And while there have been people restoring artworks since there have been art around, the field of photograph conservation is really quite new. So it formed in its infancy in the 1970s at the George Eastman, or what was George Eastman House, which is now George Eastman Museum in Rochester, New York. And a group of caretakers of photographs were developing treatment protocols and preservation standards for daguerreotypes. And these people eventually served as the folks who were mentors and teachers in the art conservation programs that developed here in the United States in the 1970s. And it was with all of these people's efforts that photograph conservation was established as a career path. So in reaction to all of these well-intentioned but rampant cleaning of daguerreotypes and sometimes ended in destruction or undesirable effects for the daguerreotypes, these folks put a moratorium on cleaning daguerreotypes in the 1980s until we could further study this issue. Nowadays, conservators are washing daguerreotypes with various methods that we have deemed to be safe and ethical, though there are some photograph conservators to this day who still will not wash a daguerreotype. But still we need to intervene with some aqueous methods sometimes on daguerreotypes, and we need to understand their long-term effects, including the modern day techniques that we use. But right now in our field we really don't have any protocols for reducing or reversing effects of the historic cleaners on daguerreotypes. We don't have any information on cleaning ungilded daguerreotypes, and we're not even 100% certain of the longevity of our current methods of cleaning gilded daguerreotypes, leaving us with the question, oh, I forgot to show you this. This is the before and after cyanide cleaning. So this is just a quick bath to show what can be removed with our modern day methods. So we're left with this question of, can a conservator wash these early daguerreotypes that have been suffering the effects of multiple historic cleanings over the last 177 years? So, of course, that question is not a very simple answer, and as conservators, we can't just experiment with these rare and early daguerreotypes, as we have to follow strict codes of ethics in our field to do no harm. And in order to reverse what we've already done, what's already been done, a thorough conservation science-based research project needs to be conducted before any method of treatment could even be considered to be attempted. So we need to understand the effects of these historic cleaners. We also need to know the effects of our current cleaners, and we need to understand how to reverse these damaging effects in a way that will be safe and preserve these daguerreotypes for the long haul. So a study of such would include mock-ups that closely replicate the early working methods of the daguerreotypists that were working in 1839 in order to see what approach works best. Then, and only then, when positive outcomes and safe procedures can be devised from these experiments, could we even think about performing conservation treatment on these early, rare, and valuable daguerreotypes. So with a project of this magnitude, a team of experts is needed. So as I mentioned before, some people are in the audience. Adrienne Lundgren is on the left. She's my colleague that I initially contacted, and so Adrienne and I, on the right, decided with her supervisor, Andrew Robb, who's also here at Library of Congress, to develop a team of people to work on this project. So we need a scientist, and the person that we chose for the project is Ed Vincenzi. He's at the Smithsonian MCI, and he's worked with daguerreotype projects in the past with a man named Mike Robinson, who's in the bottom left, And Mike Robinson is a modern-day daguerreotypist. So Mike is the person who is making all of our test samples. But together they have worked on some research with Southworth and Hawes that has been recently published. So they were a likely two candidates for working on a daguerreotype project with Adrian and I. We also, part of the research team, we are looking at the curatorial aspects of daguerreotypes and early daguerreotypists, and so we need a curatorial team, and the people that we have are Beverly Brannon she's a curator here of photography at Library of Congress, Will Stapp, who was former curator at the American Portrait Gallery, and he is the author of the one and only book on Robert Cornelius. And then recently joining our team is Sarah Weatherwax, who's curator of prints and photographs at the Library Company in Philadelphia, who holds a lot of daguerreotypes by Robert Cornelius as well. So these people will be helping us with a grant project that's application process is current, hoping to get the grant to form a database of focusing primarily on all of the works of Robert Cornelius, but also including other of Cornelius's contemporaries from 1839 to 1841 that were working in this Ungilded era of daguerreotyping. So those, we would plan to look at every one of those and study them from a science-based, a conservation-based, and a curatorial-based aspect, and make a database that would be useful for collecting information on how these early daguerreotypes, how they looked, how they were constructed, how they've survived over the years, what kind of environments they were in. That will be useful for later phases of our studies. So later investigations of this project, beyond what we're looking at now of just how the historic cleaners affect these daguerreotype plates, will include studies on protocols, how to reduce the damaging effects of these historic cleaners, and also how to develop proper storage and housing recommendations for daguerreotypes so that they don't tarnish in the future. It is of my personal opinion that doing nothing with these daguerreotypes and just letting them tarnish until they're completely black is, kind of just as doing a disservice to the daguerreotypes as, intervening with historic cleaners or, trying out new methods. I mean, we need to figure out a proper way to do it before we try, but I think we can't just let them deteriorate into nothing. So I personally would like to see this team and pool all of our collaborative resources, our expertise and our knowledge, our understanding of daguerreotypes together to preserve all of these rare and valuable, irreplaceable daguerreotypes that are the earliest photographic treasures that we have here in the United States. And I would like to see them exist another 177 years and beyond. So here's just an example of some of the works of Robert Cornelius, starting at the upper left with his self-portrait and moving to the bottom right through the years. You can see how his photography progressed. And this is a time-lapse video, so those of you not familiar with conservation, we don't work really fast. So until we can do all this research, we will just seal these daguerreotypes back up in the way that we know to be best, using our standard procedures, and wait for the outcome of the research. And hopefully I will be back along with my colleague Adrienne Lundgren in a few years presenting some positive results from our collective research. So photography is a fragile miracle of science, and I hope that it can leave, and we can help it leave an indelible mark on generations to come. Thank you very much. Any questions?
I have a question.
Sure.
A really great topic and very detailed in a good way. Assuming some people who are watching this have daguerreotypes at home or in their family collections, and that perhaps they may want to donate them to the Library of Congress in the future. That may happen. What would you suggest to them that they do or not do to these? Like, I'm guessing you'd say don't wash them, control the humidity. What else would you say? Don't
Sure.
take them apart.
So the question for the web audience was, if you have daguerreotypes at home, what should you or should you not do while you have them in your possession? Unfortunately, daguerreotypes are these things that people are so curious about, and they love to pull out of the cases and open them up, but really you should just leave them alone. People always think that there's going to be a note or a patch of hair underneath the daguerreotype in the case, but even just the action of pulling the daguerreotypes out of the case can cause damage to the daguerreotype, and if you're taking off brass mats and preservers and disrupting things, you're just opening things up to the environment. So they were put in these cases for a reason. So the daguerreotypes, you should keep them, like most photographs, not in your basement and not in your attic. Daguerreotypes are usually in the American style case, so they're sort of protected from light themselves, but you might want to keep them in an area of your house that isn't near the light or isn't exposed. It's not going to get exposed through the leather case, but in general for photographs we tell people to keep them in the dark. But yeah, I think just like leaving them alone is probably the best thing you can do, if that helps.
Can you add storage to that? Besides storage conditions, like what kind of box you should put them in?
Okay, the question is what kind of boxes should you put daguerreotypes in? Any kind of archival-based box that is made from alkaline, non-reactive materials is fine to put your daguerreotype in. You can buy these readily from archival suppliers. You can make your own 4-flat boxes. There are instructions you can find on the internet to do this. But just anything that's non-reactive. Yes?
Where are you in your research?
The question is, where are we in the research? So I'm actually here this week working on the research. We have already made the plates, so we're just in the process of doing preliminary testing, SEM testing, so it's pretty early on. In the back?
Showed pictures of examining daguerreotypes of the UV illumination. How do you limit the exposure to UVs? UV is pretty good at photochemistry and stuff like that.
Sure. The question was about how do we limit the exposure to the ultraviolet illumination when examining the photographs. So I just, thankfully for the power of digital photography today, you don't have to expose it for very long. So I really am just turning on the light, and then my photographer is clicking the camera, and a few seconds later we have an image. So it doesn't get that much light exposure to the ultraviolet.
Just keep it low.
Well, there's no like keeping it low. It's just one setting of UVC. But a lot of people ask me about light exposure, like scanning photographs. But that tiny bit of light that you get to take a photograph is not going to be damaging. It's a cumulative light that causes the damage to the photographs. I can't tell if that's a question or not. No. Any other questions in the back?
I just wanted to say thank you for a lovely presentation. We actually had, from the Preservation Science Division here, we had Mike Robinson make a number of these plates back in 2009 with very specific test components on them. We did some initial analyses, and I just wondered if they might be of interest to have them track those over time to your research.
Oh, great. We'll have to stop by then. Are there web questions, or Mary? Okay.
Well, yeah, I guess
Oh.
to clarify, sorry, if you do treat a daguerreotype, do you throw out the old case?
So the question is, if I treat a daguerreotype, do I throw out the old case? And the answer is no, we don't throw out anything. Every once in a while, a glass is so deteriorated that we have to replace it with another glass. But even in that case, I personally return the original glass to the client and keep the original materials with the object, and including the fact that if I remove paper tape seals, I will take those paper tape seals off, line them with a good quality Japanese paper, and put them back on the daguerreotype. So yeah, I don't throw out anything that is on the daguerreotype.
Could you just continue on with that and talk a little bit about attribution based on that, like how you would say the case or all those things in the light of attribution for unsigned? They're
Oh.
unsigned virtually most of them. So.
Yeah, sure. So in the case of the Corneliuses, Cornelius made very specific cases, and these are attributes to his particular workings. So, for example, the self-portrait, we do not have the original case that it was in. So this is problematic. So this is another reason why you don't want to take your daguerreotypes apart, because some of these materials are specific to the photographer's working style himself and can give us valuable information that helps determine what kind of construction and working methodology one photographer had, and it'll help us study a broad collection of materials. So and it's a pretty common practice in the sort of dealing industry to take a daguerreotype out of one case and put it in another, but even there, daguerreotype photography became very popular, and there were quite a few people making portraits by the 1850s, but some of the earlier things really need to remain in these materials that they were placed in originally, because they do provide a lot of valuable information. And so we can also tell a lot of why things deteriorate in a certain way based on the materials that they used. So if you switch out a case and we don't have the original case, we don't know how that material reacted with the photograph over time. Yes?
I was asking, do you know at the time in the 1840s, 50s, how expensive it would have been to take a portrait of Daguerre?
Okay, the question is how expensive it was to have your daguerreotype portrait made. As I mentioned, we don't have any of Robert Cornelius's notes, but there's a lot of advertisements from the early 19th century from daguerreotype studios. So it was roughly $5 to have a daguerreotype made, which was a lot of money in 1830s, 1840s. Any other questions?
What do you consider to be appropriate housing for loose plates?
Oh, the question is, what do I consider to be appropriate housing for loose plates? Loose plates are extremely problematic because they're 100% exposed to the environment. So there were famous daguerreotypist plates that were found in these wooden boxes that they used in the 19th century to store their daguerreotypes, but that have fared okay. But in general, we don't recommend any wood. But I would definitely recommend having a conservator seal up your daguerreotype in a very simple package, just so it isn't exposed to the environment. So in part of this Cornelius project, I have met with family members of Robert Cornelius who have some portraits of family members, and the one portrait that Al showed to me, he handed to me, was a bare plate, and there was no image on it. He just stuck it in my hand, and he was like, "Turn it over," and I turned it over, and it's etched on the back. It says, "Portrait by Robert Cornelius," and I'm like, "Oh, why is this in my bare hand?" So you leave it out, and it tarnishes to, there's the images are 100% obscured. So, the plates, particularly this one, really needed a housing. So, conservator is the way to go for that.
What was the wash bath in that washing video?
Oh, the wash bath in the washing video was ammonium hydroxide, which is our current treatment method. So it's ammonium hydroxide and deionized water. Any other questions? Well, thank you so much for having me here.
This has been a presentation of the Library of Congress. Visit us at loc.gov.